Hi friends, VQ has released two model question papers on the subject Automata Theory and Computability with the subject code 18CS54, and many of my viewers had requested me to solve these two model question papers. So in this video, you will get the solutions for module 1 questions of both the papers. Before I start, a message to my viewers. I thank you all for your amazing response to my channel. The very objective of this channel is to share ATC subject knowledge and help build a strong and effective conceptual understanding among the target audience. Thank you for all the feedback and motivation. I commit to make these lectures as effective as possible. I would like to thank all my viewers who have subscribed my channel. But maximum watch hours of my channels are viewed by my viewers who have not yet subscribed. So if you find my videos useful, subscribe my channel so that this knowledge reaches wider audience and they can also benefit from the same. Join me in this learning journey by just a small click on the subscription button. Let's learn together. So with this note, let us start with the first. So the first question is to define the following with examples: alphabet, power of an alphabet, concatenation, language, string. So all these definitions with examples are already explained in my video lecture of module 1, lecture 1, consisting of definitions with examples. So you can watch this video. Next question is to define a DFSM and draw a DFSM to accept the given languages. So language B, C, D and E I have already solved in my video lecture of module 1, lecture 3, session 1, designing deterministic finite state machine. This is the link, so you can watch. The one which is not solved in my video lecture is decimal strings which are divisible by 3. So let us solve it now. For a number to be divisible by 3, the remainder must be equal to 0. If not, the remainder will be equal to 1 or 2. So here we go for representing the remainders as the states. Remainder is equal to 0, labeled as Q0. Remainder is equal to 1, labeled as Q1. And remainder is equal to 2, represented as Q2. Now, in between 0 to 9, all the numbers which are divisible by 3 are 0, 3, 6, 9. On division, their remainders are 0. Hence, the initial state is the final state. Next, numbers 1, 4 and 7, after division by 3, the remainder for these numbers 1, 4, 7 is 1. So we have a transition 1, 4, 7 from Q0 to Q1. Next, for 2, 5, 8, after division by 3, remainder is equals to 2. So we have a transition from Q0 to Q2, transitions 2, 5, 8. Similarly, go for the next state. Q1. Assume At Q1 already I have got a 1. After 1, if I have a 0, that is 10. Remainder will be equal to 1. So we'll be having a self loop for 0, 3, 6, 9. Next, if I have a 1 already followed by a 1, then after division by 3, remainder is equals to 2. So for 1, 4 and 7, it will go from Q1 to remainder to state. Last, followed by 1, we have 2 or 5 or 8. Then all the three numbers are divisible by 3. So we have a transition 2, 4, 5 from Q1 to remainder 0 state. Similarly, we have to find out for remainder 2. Already we have assumed from Q0 we have a 2. And a 2 followed by a 0 or a 2 followed by a 3. Then remainder will be equal to 2. So we have a self loop for 0, 3, 6 and 9. Next, after 2, if we have 1 or 4 or 7, then all these three numbers are divisible by 3. So we have a transition 1, 4, 7 going to remainder 0 state, which is also a final state. And at last, one more transition followed by 2 if we have 2 or 5 or 8, then remainder is equals to 1. So we have a transition from 2 for 2, 5, 8 going to state 1 as remainder 1. So this is the complete DFSM for a decimal string which is divisible by 3. The final definition of the DFSM is M is equals to K summation delta SA, where K consists of 3 states Q0, Q1 and Q2. Summation is 0 to 9. Initial state is Q0 and final state is also Q0. Transition diagram and transition table. So either you can write the transition table or you can write the transition functions. So here I have written the transition functions. Delta of Q0, 0369 goes to Q0 self loop. Q0 147 goes to Q1. Q0 258 goes to state Q2. Similarly for Q1 and Q2. And finally, for a given string, we have to find out whether it is acceptable by this DFSM or not. Input string is 24. 24 is divisible by 3. Then initially at state Q0 for input string 24. Q0 2 goes to Q0 2 goes to state Q2 for input 2. Next Q2 4 derives Q2 for 4 goes to state Q0. So from Q2 it goes to state Q0, input is consumed, and the state Q0 is an accepting state or final state. Hence M accepts the string 24. So this is the complete definition of a given DFSM. So whenever a question asks to design a DFSM, you are not supposed to just write the transition diagram and leave. You have to complete the definition also. And if a string is given to check whether it belongs to that particular language, then go for deriving for that particular language. Else, that particular string. Else, take your own string and derive the instantaneous descriptions and check whether that string is accepted or not. If it reaches the final state after consuming the input, then the string is accepted. Else, after consuming the input, if is still in the intermediate state like Q1 or Q2, then the string is rejected. So this is how we are supposed to write the complete definition of the given DFSM. Let us see the next question. The next question is to convert the following NDFSM to its equivalent DFSM. And the NDFSM is given in the form of a transition table. In the step 1, we are supposed to compute the EPS of all the states present in NDFSM. To start with, EPS of P. By default, P will be in the EPS. From P, for epsilon, it is going to state Q and R. So Q and R also are included. EPS of P is equals to PQR. Next, EPS of Q is equals to Q. And if you see here, there is no epsilon transition from Q to any other state. So EPS of Q is equals to Q. Similarly, EPS of R is equals to R, as R doesn't have any epsilon transition. So once we have obtained the EPS for all the states, in step 2, the new start state of the DFSM S dash will be EPS of the start state. And here the start state is P. So EPS of P is equals to PQR. So the new start state of the DFSM will be PQR. And at present, the active state is PQR, and we are supposed to obtain the delta transitions for this state PQR. So PQRA, PQRA, see this column, we have null P null, that is P. So EPS of P is equals to PQR. Next, PQRB, PQRB, all the three here. So in this column, it goes to QR. EPS of Q is Q, EPS of R is R. So PQRB is going to QR. Next, PQRC. This column, we have PQRC going to state PQR, and EPS of PQR is PQR. So after computing delta transitions of PQR for input symbols A, B and C, we have seen a new active state QR, and the current transition diagram looks like this. Initially we have state PQR. For A and C, it is going to self loop PQR, and for B it is going to new state QR. As of now, the active states are PQR and QR. For PQR, we have obtained the transitions. Next, we are supposed to obtain the transitions for QR. So QRA, 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 we have P and null. EPS of P is PQR. QRB is going to R and null, so it is R. EPS of R is R. So QRB is going to R. QRC, Q and R, C is going to PQ and null. So PQ. EPS of P and EPS of Q will get PQR. So QRC goes to PQR. So from this we can see a new active state R generated. So the current transition diagram looks like QR, A and C is going to state PQR. For B, it is going to state R. Now we are supposed to compute the transitions for state R. You can see here RA, RB and RC all are going to null state. And here we don't have any change in the active states. So the deltas has been computed for each element of the active states. Hence this is the final DFSM obtained with three states PQR, QR and R, where all the three are final states, because in the NDFSM the final state was R, and in DFSM wherever you have R, all the states will be final states, and here all the three states have R, so all the three are accepting or final states. So this is the DFSM obtained for the given NDFSM. Next question is to minimize the following DFSM. So here also the DFSM is given in the form of a transition table where initial state is A and final state is D. So let summation be 0, 1. We'll see the operations of minimizing the DFSM at each step. So initially there will be two classes. One class consisting of all final state or accepting states. So here it is only D. And another class consisting of all non-accepting states. So in this class all the non-accepting states are A, B, C, E, F, G and H. So initially we have two classes. Next is we have to check whether this class is further divisible or not. For that we have to find out A0, A1. So A0 is going to B. B is in the second class. So A0 goes to the second class. A1 goes to A. So that is also in class 2. A, B, C, E, F, G, H. B0 is going to A. That is class 2. B1 is going to C. C is again in class 2. Similarly, we have to find out for C0. C0 you can see here. C0 is going to D, class 1. So C0 is going to D. C1 going to class 2. E0 to class 1. E1 to class 2. F0 to class 2. F1 to class 2. Similarly, in that way we have to find out for all the states. So once we have obtained for all the states, we have to find whether there is a pattern. So here we see A, B, then F, G belong to one pattern. This is pattern 1. Okay. Then C and E belong to pattern 2 and H belongs to pattern 3. So there are three different patterns we split into three classes. They are A, B, F, G in one class, C and E in second class, and H in third class. So finally, we at this state we have obtained A, B, F, G, C, E, D, and H, four classes. Again, we have to check whether these classes A, B, F, G and C, E are again possible to split. So again find out A0, A1, B0, B1, F0, F1, G0, G1. Similarly, C0, C1, E0, E1. In all these, A0 is going to B is in first class, A, B, F, G. Similarly, A1 is going to A is in class 1. B0, A is in class 1. B1 is going to C is in class 2. So B1 going to CE. So in this way we have to obtain for all the states. Again we have to check the pattern. So if we see the pattern here, A and G belong to the same pattern P1. B and F belong to the same pattern 2, and C and E belong to pattern 3 as they are similar with each other. So there are three different patterns obtained. A G, B, F, C, E and D, H. So next again we have to find out, is it possible to split AG and BF? So again find out AG, A01, G01, B01, F01. So if we find here A0 is going to B is in BF class. A1 is going to 1 is in AG class. So in this way if you find out, you can see here A and B, A and G belong to the same pattern. Similarly, B and F belong to the same pattern. So, no more split is required. And finally, the classes obtained are AG, BF, CE, D and H. The minimized DFSM consists of the states AG, BF, CE, D and H, where A is the initial state. Wherever we have A, that will be the initial state. D is the final state, so D is the final state. Coming to the delta transitions, first state is AG. AG for 0, they are going to B and F. For 0, they are going to B and F. A1 is going to A, G1 is going to G. So AG for 1 it is going to AG, that is a self loop. Next coming to BF. B0 it is going to A, F0 it is going to G. So BF for 0 is going to AG. B1 C, F1 E. So BF for 1 they are going to state C E. Here only you will come to know whether your answer is right or wrong, because both the states must go for a given input symbol to the same state. They cannot deviate. Then only your minimized DFSM is correct. So you can verify your answer here only. Next, coming to CE. C0 is going to D, E0 is going to D. So CE0 is going to D. Next, C1 is going to B, E1 is going to F. CE1 is going to BF. Next, D0 is taking a self loop 0. D1 is going to A. Last H is going to G. H is going to G for 0, and for 1 it is going to D. So this is the complete minimized DFSM. But one thing to be noted here, if you check, AG is the start state, BF state is reachable from AG, CE is reachable from the start state AG, D is reachable from the start state AG, whereas H state is not reachable from the start state. Since it is not reachable, no need of having state H. Either you can eliminate this H at the start, or you can eliminate at the end of the state. So on eliminating H, this is the final minimized DFSM obtained. Therefore, the complete DFSM is M is equals to Q summation delta Q naught F, where what is Q? Q is having states AG, BF, CE and D. Summation is 0, 1. Initial state is AG. Final state is D. Last delta, either you can write the delta transitions or you can write the transition table. I'll just write the transition table here for 0, 1. Initial state AG, BF, CE and D. AG for 0 it is going to BF. For 1 taking a self loop, BF0 is going to AG, BF1 is going to CE, CE0 is going to D, 1 is going to BF, D0 self loop, D1 going to AG. So this is the complete definition of the minimized DFSM. Next question is to minimize the DFSM given in the form of a transition table where A is the initial state, C is the final state and rest all are the intermediate states. Summation is AB. Initially we have two classes, one which is the final state. So here we have only C as the final state and rest all in another class. Say assume this as class 1 and class 2. Having these two classes, next step is check. Is it possible to split class 2 further? For which we have to find out all the possible transitions from AA, AB, BA, BB, DA, DB, EA, EB, FA, FB, GA, GB, HA, HB. So let's see AA. AA goes to B. B is in class 2. So AA goes to ABD, EFGH. Similarly, AB goes to F. F is in class 2. BA goes to G. G is in class 2. BB goes to C. C is in class 1. DA goes to C, class 1. DB goes to G, goes to class 2. Similarly, EA goes to H and F. So this is class 2. FA goes to C, class 1. FB goes to G, that is class 2. GA and GB goes to E and F, so they go to class 2. H, A goes to class 2, whereas B goes to C, that is class 1. Now if you see the pattern here, AA, AB go to class 2. Assume this as pattern 1. EA, EB goes to pattern 1. GA, GB goes to pattern 1. So both the transitions go for the same class. Next, assume this as pattern 2. BA goes to 2, BB goes to 1. So this is similar to H with the pattern 2, 1. Next, we have obtained one more pattern P3 where A goes to 1 and B goes to 2. And this pattern of D is similar to the pattern of F. So here we have seen three different patterns. One with A, E, G in one class, B and H in another class, and last D and F in the third class. So now we have obtained three classes AEG, BH, DF and C as it is. So by now we obtained 4 classes. With these 4 classes, next step is to check is it possible to further split AEG, BH and DF. So again we have to find the transitions for AA, AB, EA, EB and GA, GB. AA goes to B, B is in BH class. AB goes to F, F is in DF class. Similarly, EA goes to H, H is in BH class. EB is in F, goes to F, F is in DF class. GA goes to G, G is in AEG class. And EB goes to E, where E is again in AEG class. So if you see here, these two belong to the same pattern, whereas G has different pattern. So we can split AEG into AE and G. Next, for B and H, BA goes to AEG and BB goes to C. Similarly for HA, HA goes to G, that is AEG, HB goes to C. And here these two belong to the same pattern, so no need to split this class BH further. Similarly for D and F, if you see D and F also share the same pattern, and further there is no need of splitting D and F. Finally, there are three different patterns split into three classes. One is A, E and G is now split to A, E and G, BH as it is and DF as it is. And finally, now we have four classes. Instead of four classes, we have five classes. Class 1, 2, 3, 4 and 5. Already we have checked BH is not needed to split. DF also share the same pattern, no need to split. Finally, we are left over with to check for A and E. So AA goes to B, B is in BH pair. AB goes to F, F is in DF. Similarly, EA goes to H, H is in BH. And EB goes to F, F is in DF state. So you can see here both share the same pattern, so no need to change the classes or splitting the classes. So by now, no further split is required and the classes finally obtained are AE, G, BH, DF and C. The minimized DFSM obtained is consisting of 5 states AA, BH, DF, G and C, where initial state is A, so we have AE, final state is C. Let us complete the delta transitions. A goes to B, EA goes to H. So A goes to BH. B goes to F, EB goes to F. So EB for B, it goes to DF state. Next, coming to BH. BH, A goes to G, A goes to G, and B goes to C. For B, it goes to C. Coming to DF. DF. A goes to C and B goes to G. Coming to G. GA takes a self loop. GB goes to E. E is in state AA. Last C state, which is the final state. For A, it is going to state A. A is in AE. For B, it is going to C, that is self loop. So this is the minimized DFSM obtained, where initially in this DFSM we had 3, 4, 5, 6, 7, 8 states reduced to 5 states. And finally, the DFSM obtained is M is equals to Q summation delta Q naught F, where What is Q? Q consists of AE, BH, DF, C and G states. Summation is AB. Initial state is AE. Final state is C. And at last we are supposed to write the delta transition. So either you can write the delta transition table or delta transitions. So the minimized DFSM delta table consists of A, B. States are AE, BH, DF, C and G. A is the initial state, C is the final state. AE, for A it is going to BH, for B it is going to DF, BHA is going to G, BHB is going to C, DFA is going to C and B is going to G. C, A is going to EH and B is taking a self loop. For G, A self loop and for B it is going to state AE. So this is the complete definition of minimized DFSM. In the next video, I'll come up with the solutions for module 2. Thank you.